What up, and welcome. I'm Matthew Msingati, the designer and developer. This is my YouTube channel, Coded Design, where I teach coding and user interface design. This is somewhat a very different and a unique video from the videos that I usually do. When I was walking to the shop, I picked up this old electronic component, and to me, it looked like a piece of code. So I'm hoping in this video, I will really convince you not only that this looks like a piece of code, but it is a piece of code. Let's just take a look and see what it might be. Okay, first of all, we have different sections of this device. Let's first look at the front or the facade or the face of this device. Just by looking at it, we can have an idea of what it might be, because it looks like here this is a slot for putting a CD, or maybe, as it is written, a DVD. And then also looking at the size of it and the shape, it looks like it's maybe it's a DVD. However, at this point in time, as much as there is the word DVD written here, we cannot really conclude. We just need to take a closer look at it to see if really this might be a DVD, because it looks like very small to a what's this, a home kind of a DVD, or just like, yeah, you know, those normal home theater systems. So it's very small. It looks like it was designed to fit in a car or something. So this is the face of it. So, and then if we look at the back, we can see that it has got a circuit board here, a small circuit board, and also this looks like it's a power cord, the main power, and also it has got another component here. So what I'm learning from what I see is, if you look at the face of this device, you cannot really see this circuit board. As you can see that it has been hidden from you, and this interface looks very nice. This is the power button, and also this power button has been designed in such a way that it's easier for you to switch it on and off, and also it has got some labels there to tell you that it's a power button. So what I'm learning from this, from the construction of this device, is that it has got some sort of a face that covers all the technical things or the complicated stuff about the device that, as a user or a customer, I don't really need to know about, or I care less about. What I care about is the functionality. Can I press the button? Can I sense that or feel that the button has been pressed? Just by touching and feeling the button, can I tell if the button is on or off? Obviously, based on the design, as you can see that now it's flat, but once it's off, it's there is some sort of this button is protruding or coming out. So based on my knowledge about the switch on button, I know that once it's flat or more deep in a component, it means on. Once it protrudes or move closer to me a little bit, that means it's off. How does this relate to software development or coding or programming? Object-oriented programming is not different from the technique that has been used here. This is an interface. This is a class. This is an interface. What it does, it covers or it hides all the functionalities, things that we don't really need to know about. So that's what an interface does. That's why in software development, you are always advised, or it is a good programming practice, to code to an interface rather than the actual implementation. Let's say in this device we were given this part as it is, or maybe this one. As you can see that here there are components that might be sensitive to water, in case maybe there might be some drops of water that might fall in here and it might cause a damage. Also, looking at these wires, because this device has been exposed, as you can see that there is no head which was supposed to be here, which looks like similar to this one. So by having a face or a cover or a container, the manufacturer was protecting these components, because as a customer, my interest or the contract between me and the device, or my interest is to use the device, not to fix it and not to open it. This technique or this approach is the same in programming. Why must you have an interface, a class that is an interface, and another one that implements that interface? The reason is this face acts as an interface so that the whole program must not be aware of this component. Why are you going to use an interface to hide all the technicalities so that the whole program might not be aware of this part? It only knows this part. The reason is, let's say in your code you've got a problem with this component. If this component was integrated or it was coupled with this part, so it means that if this component has got a problem, it means that you have to replace the whole thing. That's what usually happens in programming. If somebody wrote a spaghetti code, or a developer has not been careful on how he writes the code, if the good programming practices, the design pattern and solid principle has not been applied, you write a tightly coupled code whereby if this button, as you can see that we have lost this button, if this button is lost, it means that the entire application is broken or it's useless, because once this button is removed, this also doesn't function, this also doesn't function, and this also doesn't function. But if you code to an interface, it means that if this section or this class has got a problem, as you can see that there is a cord that connects this class and this interface. So it means that you can plug out this component and change it with another component without affecting the interface. So that means the whole program, your whole application is not aware of these components as something that has been changed, because the one that has been replaced with, it conforms to exactly, it keeps the contract of communication between the interface and this class and this device, and that makes it seamless to the user, the person who is just looking at this part. So you are not aware if this has been replaced. Why are you interested on replacing things? Why are you going to code to an interface? It looks like you feel like you are going to make a lot of changes. Yes, changes are going to happen. The app is going to improve, and it's going to get 1 million users. New features will be required or will be requested. So in your coding or in your system, you might need to replace this class with another class so that to make it extensible. Now let's talk about the solid principle, the open close principle, the O in the solid principle. It says that your class must be open for extension but closed for modification. If this was a DVD, a full set, you will see a new one from the shop. You will see that, or you would have noticed that it's sealed, it's closed for a modification, but it's only open for extension. How this component or how this device might be open for extension? As you can see that deliberately the designer or the manufacturer has left out some things that we can use if we want to extend the functionality of the device. This has been planned, and it has been in the manufacturer's mind from day one. So what I'm noticing in YouTube tutorials, and also developers, and also when I'm downloading some sample PHP project from the internet, I just realized that we are not careful enough on how we structure our program. We have the HTML part of our program integrated with the controllers, with the functions that connects to the database and everything. As a result, I feel like these are not application. They are just mere solutions, meaning that they just get the problem done. When it comes to making them a real life application, obviously they will fail the test, because number one, when I'm reading through this code, I'm struggling to understand things properly. So in closing, let's relate this to the MVC pattern, the model, view, and the controller pattern in programming, in object-oriented programming, or in software development industry. So this is some sort of a view in a way, because it interacts with the customer. It might act like it's interacting with the client code, so it interacts with the customer. So this is some sort of a view, because this gives you an insight, or it's a window to this functionality. So this might act as a view, and obviously somewhere here in this processor, this might be a controller. This is a controller. So meaning that this deals with all the logics, the decision that must be taken, so that maybe a tray can come out here and it can go back again with the CD. Then it's gonna be read somewhere, but whatever that reads the CD has to communicate with this microchip, is the one that makes decision. So as you can see that there is a separation of concerns. The face is concerned and is beautiful, and it has been designed to interact with the customer. As you can see that these are the things that you can read. However, this has not been designed as a controller to interact directly with the customer, but it will be fed the information from here. So the information that we'll receive might act as dependencies, where we'll talk about the dependency injection design pattern, meaning that, let's say, the information that comes in here, it's being injected into this dependency injection container, and there is a method or a class as this microchip that makes use of that uses the dependency that was injected. Okay, let's say that all the information that goes out to the TV, let's just pretend like it's our model, meaning that it's more like connecting to the database. So this to me really relates to an application or a system. As you can see, if we take a closer look in this circuit board, this is intentional. This has been planned. I would like to believe it has been drawn down, and you can see just by looking at it, it feels like it has been designed. But us as developers, we want to code as we wish. We don't do the UML diagram, we don't do the class diagram. Whenever we are asked to do something, we just jump into Visual Studio and start typing. Now when it's time for the client to make a lot of changes, then it becomes a problem. I am also a victim of that problem. I have lost a couple of jobs because of I couldn't keep up with the client changes. So to me, this looks like a piece of code. It has been designed intentionally. So in closing, I wish as developers we can think like engineers. We can think and do things and plan things like engineers. As you can see, this is a very sophisticated system, but it acts as intended. If this component has got a problem, the system has been designed in such a way that you can take this component out and replace it. That is it for me Matthew Msengati. If you feel like this video has added a value in your overall understanding of the software development and also the interface and the MVC pattern and clean code, please